Good afternoon, everybody. Welcome, everybody, to our last event for the summer break. So before I hand it over to Andrea and Mirko, let's do a short recap on where we touched on ecosystem security in this series before. So first, we started in April with Alicia, where she interviewed Sherilyn from NIST about the new version of the NIST cybersecurity framework, where cybersecurity supply chain risk management was already more prominently included. Then we turned it up a notch and we had another meeting where I interviewed Joseph from the Dutch Railways to talk more about the practicalities. So, third party risk in the context of their preparations for the NIS2 directive. At that moment, it was already becoming clear. We talked a lot about the complexity of vendor risk. Getting it right is easy on paper and extremely difficult in practice. So if you miss these presentations, just drop me an email at the end of the event, and I will send them to you. For now, today we're going to turn it up again and dive into security and software supply chain. So this may be one of the most complex challenges that we need to solve today. It was quite difficult to find speakers that could cover some of the topics that we wanted to include, and also with some hands-on experience in the domain. So I'm extremely happy that Mirko has agreed to talk for you today. And as always, Andrea, we're always very happy with your support for the CISO tribe. So this is the agenda for today. Andrea will set the stage, introduce herself, introduce Mirko, talk maybe a little bit about her own background in this domain. Then Mirko will take the floor, do his presentation. And after the event, I think we agreed, Andrea, Mirko, that we would save the questions till the end of the event.
Yes.
But the questions tab is open now. So immediately, if you have a questions, just look at the right bottom of your page, press the questions tab, and immediately ask the question that you want to ask Mirko. Mirko is a very busy guy. I don't know when we're able to get him again. So if you want to get the most out of this hour, then ask as many questions as you possibly can. So this is the CISO tribe. I think you know us by now. We have a number of focus areas defined that we talk about a lot, that we also organize some events like these and some other activities around. Yeah, for the sake of time, I'm gonna move it over to you. That was a bit of a cliffhanger. The floor is yours, Andrea.
Thank you, Wim, for the kind introduction. I'll just tell you very shortly who I am. It's all right here on the slide. And I think looking at this topic, something that always is interesting to me, and the reason why we maybe even did this in the program is looking at the topics, as Wim already said, from the legal legislation aspects, and getting things into the nitty-gritty of practice. It's something I'm always very interested in personally. Looking at specifically this topic, working at the railways, working with something like a train where you have many software components, trying to sort of wrap your head around how can I get a complete view of all of this software. And I think also anybody working in an IT environment like I am right now, which is very cloud oriented, it's a lot of the same kind of topics coming back. So thinking about the software bill of materials and trying to implement this is something I think that should be of concern to anybody in these roles nowadays, looking at all the legislation coming at us. So I'm very excited to introduce you to Mirko. He's been working in this area for way longer than me. But he's a recognized activist, expert, speaker, publicist, and researcher. It's very broad areas here, but very exciting to be talking to you, specifically in the field of cybersecurity and the Internet of Things. He's worked as a member of the expert group on Internet security of things at the European Cybersecurity Agency, it's ENISA. And he also advises the EU Commission and the German government, and is an expert in this area as well. So I think it's very exciting to have somebody who's really taking this topic on and making that bridge between how can we do this in practice and how the lawmakers are looking at these aspects. So he's also got a background in hacking, beginning at the very young age of 14, looking into IT vulnerabilities. But he, luckily for all of us, decided to use his powers for good instead of evil, and he's helping us work on solving some of these major issues that we have in our environments. And he's also, in the same context, interested in nonprofit projects such as open data and IT education. In 2018, he founded SVIN with the aim of increasing cybersecurity in the AI and software supply chain specifically, and working on providing software solutions. So I'm going to hand it over to you so you can get us started on talking about why we invited you here today to take us down into the nitty-gritty of how this all works. And as Wim already said, if you have questions, please go ahead and put them into the question box, and we'll get back to those at the end when Mirko's done giving us his presentation. The floor is yours.
Awesome. Andrea, Wim, thanks for inviting me for this event. And yes, I've been asked to talk about software bill of materials and the impact on the supply chain and how to deal with all that things in 20 minutes. And to be honest, okay, let's give it a try. Maybe I need half an hour, but it should not be boring. There's a lot of topics we could cover, but I will try to do it a little bit from the high level, and then let's see how we can deep dive into the certain topics within there. Andrea gave a very good introduction about myself, and at the end she said that I had founded a company in 2018, SBOMs, here in Germany, and this is just the small promotional slide. Sorry for that, but if you are interested in what we are doing as well on SBOMs Labs, especially on the research side, just step by. We are well recognized now for what we are doing. We have several super interesting research projects ongoing in space of supply chain security, but as well AI security, software supply chain security, and data security for AI systems. And hacking AI systems is as well a new fun, to be honest. And we are doing a lot with that. So just get in touch with me if you would like to know a little bit more about this. And as well a little bit about the company. I mean, I have the pleasure to talk to you today as an expert, but I'm really surrounded by many brilliant people in SBOMs working together, like Rob van Kranburg, who is doing a lot of stuff in the European space as well, or Raphael Yahalom at the MIT in Boston. So it's just a couple of people who are doing really great stuff. And as well, we are covered by a super excellent board with former CEOs from large industrial companies. And this is really a pleasure to work with all these brilliant people. Beside all the rest, working with customers, it's great, but working with brilliant people is the most exciting stuff. So we were talking, I mean, you have heard about the software supply chain, and obviously you're doing that because you have the feeling that something is going terribly wrong. Obviously, we should not talk about the software supply chain. And yes, it's not a new topic. It's like always in cybersecurity, it's not a new topic. I mean, remember 2010 when Stuxnet was hitting as a first really cyber weapon the supply chain of many industrial companies, particularly with a build malware for one specific use case. But it's almost 13 years ago. And we can imagine that the industry, by the attacker side, has learned a lot in that time, how much impact they can create by attacking the software supply chain. And then if you look into how this kind of attacks are evolving, I mean, we have now the latest one with MoveIt. Welcome. It's not on that slide. Sorry, my team was not fast enough to prepare that, but actually the next attack is currently running. I think there are many eye-openers here. It's like Kaseya is an eye-opener, but to me, it was like SolarWinds Orion was a very big eye-opener. And of course, Log4j last year. Now we have MoveIt. Why it's an eye-opener? Because it's not that this is a new type of attack. It's more an eye-opener in the way how we respond as companies to that risk. and how is our risk mitigation ongoing. And to be honest, while the attackers are very specific, very targeted, very quick, to me, the industry is almost like a herd of insane people, don't know how to navigate best on their risk mitigation. We are losing a lot of time. We are doing things 2, 3, 4, 5 times, patching servers and whatever. There's a lot of energy we are wasting in there, and as well resources, and as well human resources. Keep in mind, I think for Log4j, this was very interesting. It was within the first 12 hours, we've seen automatic attacks carried out on servers targeting the Log4j vulnerability. While many customers were still asking their suppliers, is Log4j in my product? And their suppliers were asking their suppliers, is Log4j in my product? And the suppliers of the suppliers of the suppliers were asking, is Log4j in my product? At the end, it was maybe going to a single developer in Eastern Europe or Asia, and they were reporting back, yes, Log4j is in there. No, Log4j is not in there. It took about 4 weeks, 3 months to get the entire downstream and upstream of information. Why 12 hours, within 12 hours, it has been completely automatical attacks on Log4j. And then the question is, I mean, this is a super waste of resources, and as well, it's a super waste of time. And I think we can't afford wasting both. Now I was asked to talk about software bill of materials and what is the role of software bill of materials. And to be honest, some customers already had as well software bill of materials in place when Log4j was happening. However, they were asking their suppliers, is Log4j in my product? And this means there's something double wrong in there, because it means they don't trust their own software bill of materials. On such a serious incident, there's obviously 2 situations. One situation, companies who don't have software bill of materials in place, this is already a bad situation because you have to ask your suppliers. So there's place for improvements. But there's the second group of companies who had software bill of materials in place, and they were still asking their customers, is it this Log4j version? Are you sure? And this is even more worse, because it means that software bill of materials have been installed and they are running, but maybe more for compliance issues than on the real purpose to help us in risk mitigation, identifying threats, mitigate the threats. So obviously, something is going as well wrong with the software bill of materials at that state. So there are a lot of things we have to discuss in the industry, how to improve it, not only by installing software bill of materials, but as well how to trust them and how to improve our procedures on risk mitigation. I like this slide. It was like with 145,000 lines of code, we were able to fly to the moon, bring men on the moon and back again. It's in a modern car, connected car, it's about 100 million line of codes. And if this will be a full autonomous driving vehicle, it's estimated to have 300 million lines of code. I mean, that's the level how modern software deployment and how the modern software industry and processes are creating code. We are not as well very efficient on how we are implementing code in our product. One reason is hypervisor technology, but another reason is just as well how the industry works. It's all about saving developer resources, and by that, developers are not so much trained on doing or building products with less code. It's the tendency is more to build more codes in there. Why it's so important to discuss about this? Because if we look in statistics and what is the quality of code, then it's this. I mean, up to 3 errors by 1,000 lines of codes. And if you have programmed yourself, you know what it means. It's just, I mean, you're creating code and you have to debug it. But however, there is, and even for complex products, if you go to compile them and whatever, there are so many elements in there where you can place vulnerabilities or bugs or any errors in your code which can be then misused, that it's clear. I mean, that's the true statistic. So if we take this modern car, then it's about 50,000 to 300,000 potential errors in there, bugs, vulnerabilities. And how much of them do we identify with software bill of materials? That's as well an interesting question. So obviously there are more unknown bugs and errors in your products than even the known errors if you have software bill of materials installed. But this is not a reason not to install software bill of materials, because you say, well, nothing will change, there are errors in there. No, that's not true. But we need to take care, we need to be very aware of whatever we get into a product and is shipped into product is full of errors. And if we want to go to proper risk management there, we need to know at least the known errors and vulnerabilities to make a decision on how to treat them in our products. That's the reason why worldwide and everybody in the regulatory side have to come to the conclusion that software bill of materials are playing an important part. And I've just put this, I mean, it's the same like for groceries. I mean, there's as well good reasons why Nutella, they are printing what is the ingredients of Nutella. Because obviously there's a risk in the product itself. It's a health risk for yourself. And there are reasons why it's printed on there, and then you can take the decision if you want to eat it, yes or not. And we need the same procedure as well for software, and this is really new. So Wim was asking me, when we were talking in before, yes, it's all great. I've heard that you're working with your research on, let's say, more advanced software bill of materials. And I said, yes, it's interesting. Yes, we did 2 projects on there within complex supply chains. And he asked me to tell a little bit about what are distributed software bill of materials. And to come to this topic, you need to understand 2 things. First of all, the Nutella ingredients list is very simple, but as well, the supply chain is maybe complex. But for software, the ingredients are, for complex products, much more difficult to collect through the entire supply chain, because there's in the product itself a huge supply chain. If you have talked about trains, for example, I mean, super complex products. Take the aviation industry, the automotive industry, as well machines. I mean, there are huge supply chains in behind from someone, for example, who is providing a silicon processing component, which will be then put into a sensor, which will be then put the sensor into a sensor product, maybe with safety relevance. And then the sensor product will be put into a component of a machine, which is doing something. And this whole component is then sold to the machine vendor who is building the machine. So there are really large supply chains in there. But a sensor today means it's running software. So, and if you could have a look in the regulatory environment, it would be, if it's a critical product, by, for example, the Cyber Resilience Act or other acts like for cars, the WP29, you need to know what is the software in our product and where it's coming from and who are the vendors and the suppliers of this. And this is complex in the supply chains, because even there are not supply chains, and this is what we want to show you here with this graphics. We are talking about supplier networks. It's if you're going down to the end tier suppliers, they're shipping their products to many in this kind of supplier networks, and they're putting it into their products and so on. So it's a really complex ecosystem, and how to collect the ingredients there if you don't track it at the moment, or if you track it, if you use Excel. I think even if there are Excel artists out there listening to that, I can believe this is even for Excel artists a challenge where they maybe stress the Excel product to the end of the capabilities. This is a huge supply chain which needs to be tracked, and the decentralized aspect maybe will help for that. Even for Log4j, keep in mind, at the top there's an OEM. So he was asking, in this entire supply chain, is Log4j my product? You can imagine that for an N-tier supplier, this is a very difficult question because he has to answer this for many suppliers, which means there's as well from a resources aspect of resources, and there's a lot of stress then for these end suppliers to answer this just in time, which is almost impossible to organize that in a traditional way where you don't burn people or you're not losing time. So that's why we were thinking about not only software bill of materials, but however, how can we increase the flow of information and the trust within this software supply chains. We're doing, it was last year, it's 2000, Expo Day 2222, I see on the slide, very good. But it was last year, not in the future. So we're doing, for example, a project together with DXC, Luxoft, and a US company, Excel4, who are providing over-the-air updates for cars. And what we did exactly, we were tracking software components from certain vendors through the supply chain, and then put them or prepare them for the over-the-air updates for cars for certain reasons. And the vision in behind is much broader. It's really about how can we provide cars to become self-healing vehicles. What does it mean? It means that we not only know the software bill of material, but that we can put as well essential information out of that to heal risky vulnerabilities in the car or misfunctionalities. And by that, you need a very exactly state of what is the software ingredients of the car to make this decisions on an automatic level. And that's what we're building here with DXC technology last year. Why we have called it the SBOM? The SBOM means it's distributed. It means we are not storing the information of a software bill of material at a single point. What we provided was a system, it's a ledger-based system, where we're using as well IPFS, for example, as decentralized technology, where all vendors had a possibility to store their specific software bill of material in the ledger network. And OEM has the possibility to grab this information instantly, and then two things. First of all, checking when an update, for example, is coming, is the update already included in my software bill of material for my current product, but as well giving the possibility to model the software bill of material based from their product, from their bill of material of their product, based upon the information which is provided by the companies who are contributing this information to the ledger. And it has shown that this principle has a lot of advantages. One advantage, for example, if a new vulnerability is popping up and vendors want to provide updated software version, they can commit it to the ledger. And all parties who are within the supply chain are getting immediately the information that an update is available, as well with all these trust principles who are tied to it. Which is a parallelized process, by the way, compared today in a traditional supply chain where everything has been going through upstreams and downstreams. So by that, we are reducing the time of providing the information of software builds for particular products, and as well for the patches and updates there. If you look at it, let's say in a more specific way, of course, there's the general idea is needed, how companies can provide their software information to such decentralized systems. But as well, the question is, how do I deal as a company with my own development lifecycle systems then there? Because if we look at software bill of materials, it's not only what is the specific format you are creating software bill of materials, let's say Cyclone DX or whatever. It's as well deeply connected to the process how companies are developing software. And we see as well that currently a lot of companies are struggling because they are not going to see, or they haven't reached the status of, for example, CI/CD pipelines yet. But for many complex products in the future, like take a car, it's needed to have a very agile CI/CD pipeline in the back, because you want to provide updates very fast, which means that you have the whole cycle, like how software is composed, tested, how software is running through as well regulatory checks or legal checks, and then shipped over the air, needs to be very fluid. And you can't do that without CI/CD pipeline. Everybody knows it in the industry, but it's very hard to implement it, because you have to transform as well an entire system which is already building software since decades on a, let's say, outdated way for the modern vehicles. So if you are stepping into software bill of materials, you're stepping as well immediately in the way how software is produced within your company and within your products. And then it's not only adding a software bill of material tool towards your processes. Often it means as well that you're changing completely the CI/CD pipelines of your products. How do you do product maintenance, life cycle? Because all this is connected then to the software bill of materials. It's not only to know the ingredients, it's as well to know which ingredients needed to be updated, which ingredients have certain vulnerabilities, where in terms of supply chain attacks is software coming from, who has provided it, and what has been the quality measurements on certain software stacks. And what we did here in this project, we have provided a lot of tooling around that. I mean, I said we are storing this information on decentralized ledgers, but there are as well a lot of toolings around how to integrate that, for example, into CI/CD pipelines, so that from a developer's perspective, they don't have more to-dos in a CI/CD pipeline. It's just simply tracking all the informations, collecting, storing decentralized. And then when you want to create your software bill of material out of the bill of material of a product, it's just part of the process. There should be no additional burden for anyone in this building pipelines by introducing software bill of materials, because otherwise we are running as well in resources problems. And then if it's a resources problems, it will be bypassed. Then you can't trust your software bill of materials. And then we are again at this vicious circus that we have collected informations we can't trust. And in case of an incident, then we are asking our suppliers and not our software bill of material if there are any vulnerabilities in there. So if you look then inside, if it works perfectly, and then as well to understand what is the power of a software bill of materials, that you can build up on a model of relationships of your software. And that's the real power, because with the model, what is the software relationships between other software, between other components, as well components which are maybe provided in the cloud and so on. So there are many things which are complex relationships in the modern software development world. If you have this full picture built up on relationships of your software stacks, you are able to go for risk threat assessment. Then you can go really for this threat intelligence you need to manage all these challenges which are needed in the modern world. So one question, for example, what we often see is like, do we get an idea of are we on a direct threat path, or maybe to a relation to a party which is under attack? That's not so easy in complex supply chains. But within the informations we are collecting and all this context informations we have out from the ledger, for example, we know immediately if a certain information or product is in a connection to an ongoing current threat. Like if you take SolarWinds Orion, we would immediately know that the threat attack path is connected and that you need to take actions. And maybe the action is not to ask your supplier to get an answer. Maybe you can take immediately the action within your products or your own network to block certain components or certain attack paths which are connected to this product. So it's all about getting this context informations, how the software is connected within your product and other services, and then you can put on top the information layers of attack paths and known attacks to identify if your product is really in a line of fire, under fire at that moment. And it helps you then to go to the right decisions on risk mitigation. It's all about reducing you're reducing the time, speed up your actions, and as well for the actions, put them on the right spot, and not spread your actions among all the possibilities. It's just put the actions on the right spot, because then you have the possibility to increase your risk mitigation. We did this as well, like one example we did here from the car space. We can do this really with the information now on an entire modern vehicle architecture, and this is one example. A modern vehicle architecture, it's not so different like from any other IT networks, because it's an IT network in there, and it has segmentation of networks. It has ECUs in there, which are connected assets, sensors, actors, and so on. So, but what we can do is really to do a new context view on what are the risks in the product. And this is rather interesting because, as I said, if you have 1,000 errors per lines, it's clear that there will be always risks in the product. You can't go to a zero risk level because it's dynamic. New software components are being added, software components being changed by vendors. Even if you have mitigated one risk, maybe 2 new risks will pop up. And by that, you need another way how to handle and prioritize this stuff. And what we are doing here is we are collecting all the risks we know from the software bill of materials, like the CVEs, the known CVEs. But we are adding other perspectives, like are the CVEs on a current attack path? Are these attack paths can we match them to the components or to the architecture of certain architecture elements? As well, some other aspects like what is the distance to vulnerable components. So for example, if we know there's a super vulnerable component, but what is the distance from another component towards it? Like for example, if you have a system which is controlling your brakes, the ECU, which is controlling the brakes of your right front wheel, we can immediately estimate what is the risk for this component if another component, which is maybe far away, have been a known vulnerability. So by adding context to software bill of materials and other databases and other factors, we can create really a added value on this view of my software stacks and risks, and then giving a precise information, where should I patch first? That's the most important part. And for the example for DXC, it was even more complex. It was not only where patch first, because there are some components which can be fixed by over-the-air updates, but as well, for example, where do you need to go for a recall? Like what kind of cars I need to send to a repair shop because the problem is so serious, it can't be patched with an over-the-air update. Someone needs to do it in a repair shop, taking care of this component, maybe replacing it or do new calibrations, safety audits, and so on. So this is the world we are stepping in, not only with cars. You can put this on any connected products, even which they are super critical, like robots, on factories and so on. So I think it's a great new world we are stepping in, but we need to discuss the best way going into risk mitigation, and software bill of materials are one part. If you have a software bill of material running, it's great, but then you need to go to the next, how to take the best out of the information this bill of materials can provide to you. And adding context to this is really the key to do that. And by that, thank you very much.
So thank you very much for your presentation there, Mirko. I'm very impressed by some of the things that you're showing us. I love the fact that you're trying to get us all out of Excel, because I think that's going to be very helpful. It's a personal pet peeve of mine. And we've got some questions here, and obviously the question box is still open. So if anybody should have more questions that they'd like to input them, you could go ahead and put those in there, and I'll pass them along this way to Mirko. So one of the questions that popped up in the chat box is how you think maybe generative AI will be able to support this undertaking. Do you see a role somewhere in there for this kind of technology, and is it something you're currently investigating?
Yes, I love that question because it's so obvious. Because if you have a complex problem, the answer sometimes is always, oh, let's use generative AI on this. But obviously, it's not so easy. But there are good things in there. Let's say, like, if we look at risks and this kind of networks and complex products, and the car is as well a very good example for that. Because cars, they have complex software stacks, but even if you're introducing a new car model as a vendor, you're not completely changing the entire software stack. Let's say it's 95% of your software stack is very similar to the stack of the previous car models. Why? Because it's about industrial software development, so you can't build up entire software stacks from new car models. But it's as well a regulatory topic, because if you have already the regulatory approval for some certain software stacks, you want to keep this approval status for new car models as well. This is more an economic aspect.
Yeah.
So it means if you look into the structure of software, and what I've shown is you this graph model of, if you look in the graph model as a pattern, and this is about patterns now, because these patterns can be represented as well as risk patterns. So, and by that, AI is a brilliant tool because it allows us to identify risk patterns. And this is really the power of AI for this kind of, because the graphs are super complex. So the question is, can we early identify risk patterns, even best during the software development of such products, and can give back the developers who are working on a specific component or specific elements inside cars, for example, can giving back them the information, oh, what you're doing currently is just triggering a certain risk pattern. So giving them hints that they change something, because on complex products, you're working on one spot and you don't know what is the context of the impact of your work maybe for the entire product. Yeah. And this is something which we can create and where AI is really helpful during the development process, which is prevention, almost a case of prevention. But for detection and reaction, it's as well very helpful, because if we have these graph models and we know attack paths, for example, we can map them and we can find out the similarities between attack paths, known attack paths, and patterns in your software stack, which will allow us to identify if certain attack paths are maybe likely included in your product. So yes, generative AI has a lot of potentials in there in this complex products manner. However, to use it, we need a lot of data, not only trusted data at this point. So we really need to trust the data of our software bill of material, and we need additional contextual information about that. And that's really the key point. It means we need to collect more data than only the software bill of material. And this is really critical.
And I think looking at the examples you've given us, it reminded me of some of the tools that we currently have that are mapping things like connectivity and also vulnerabilities now. So do you think that these would be places where you might already even be getting some of this data that you could use for that? Or is it different data in your experience?
No, it's exactly what we are using is, for example, the baseline is the software bill of material. And then we are looking into data, for example, let's say, what is the network, the physical network structure in the product, which is not, I mean, this is not originally part of a software bill of material. We are looking at a physical network. This is one. Then we are looking at on cars, for example, it's the TARA. It's a risk management approach for safety risks in a car. So what components have a high safety risk, for example, and how they are connected to other components, which we can then overlay as well in context. In production area, like operational technologies, it's health, safety, environment information. What kind of your components have the biggest safety risk towards health, for example? And then it's a robotic cell. If there's something going wrong, it could harm people. And by that, you can change the prioritization, which bugs, vulnerabilities are needed to patch with the highest priority. Because obviously you can't patch them all. That's the main message I have to you out there is you can't patch them all.
Yeah, I was wondering if that was part of this message implicitly. And I think that that's a very interesting thing just even to touch upon during this little discussion right now, because obviously from a compliance perspective, if you're looking at things like the NIS, I know that at least the Dutch government has at times been known to want to mandate patching also in the operational technology environments. And obviously what you're telling us is, well, that's nice, but it's not going to happen because there's just too many of them and you don't even know which ones you have. So
Exactly. It's like, I mean, this is the Wonderland perspective. You can patch them all. No, it's not possible. So if you are a company, I mean, you have to face two things. One is, of course, regulatory compliance, because with NIS, your management is getting liable. That's a difference. I mean, if the management is getting liable, okay, we have to take care for cybersecurity, maybe. But then it means maybe if the management is getting liable, we need a software bill of material. Great. Oh, we have it? Check. But that's not true, because it means that you will have vulnerabilities in your product which you can't fix. One reason is you don't have the resources to do that. If you want to invest in the resources to do that, you can stop your business immediately. It's not possible. It's just from an economic reason, it's not feasible to do that. So there will be obviously vulnerabilities in products which will not be fixed. And if this is the fact, then I think you should take care to show that you fix the vulnerabilities which have the potential to be really high risky in terms of being exploited, actively being exploited, or actively creating a huge impact towards your citizen, towards your customers, but maybe as well towards your company. It could be as well your reputation and so on. There are many reasons why. But obviously, there will be vulnerabilities in there which are looking super scary if you look on the CVE score, like a 9 out of 10. But in fact, if you look at the context of your product, it's not a risk which can be actively exploited from an attacker perspective. Because maybe it's too far away, the attack path is too long to reach it. If you are, as an attacker, will follow this attack path to reach it, and then you can exploit it, but the impact, let's say, for the attacker is low, it could have a 10, but why should I care about that? Because there are other low-hanging fruits on the way of this attack path which are more valuable for the attacker. And then you just need to take care to close this one in the priority. And then I think you're stepping into a situation where you can handle with this uncertain situation you have in products. And there will be always uncertain.
Definitely just looking at the sheer number, something is going on that you're not aware of. I was also personally interested in hearing more about what you were talking about with the on-air versioning and the self-healing. I would have the idea that maybe some of our listeners might think, well, then we're going to be connecting cars to the internet, and nobody thinks that's a good idea, maybe as a sort of like basic starting point. But obviously you're saying something different here. And so I'm wondering if you might want to just go into that a little bit more for the listeners.
Yeah, first of all, we don't need to care if it's a good idea or a bad idea. It's there, and there's a regulatory environment requirement that they need to be connected. I mean, that's the fact. So what can I do? All new cars were shipped in the European Union are connected cars. That's a fact. Okay. If it's connected, you can hack it. I mean, that's as well for sure. However, the self-healing functionality and what we have done together with DXT technology in this project is as well awesome. I mean, it's like at the moment, even, for example, I don't tell you my car brand, but it's a German car, and I'm really disappointed about it because I know that there have been certain recalls where the car has been put to the dealer, to the repair shop to do the software updates. And the best would be, if we want to be just in time and there is a certain vulnerability, of course, that we can fix the problems with over-the-air updates. But this is it's really a complex topic, to be honest, because it means because no car, from a software perspective, no car is the same. They all have different software stacks and configurations in there. So you need to get a lot of context information about the software stacks to find out if an update can be applied without problems. And then you have and this the self-healing idea, and what you've shown there, that we can identify the groups where the updates can be applied with no problems. And for the second group, which will cause problems, to immediately dispatch them to the dealer so that it can be applied with the repair shop, because you need two options for cars. And as I said, it's a safety relevant topic. So there are as well some certain components where you can apply the update by software, but you need to check it, like you need to check the brakes. Or if you have a windshield component, for example, which has a lot of sensors in there, you can apply software there, but it needs a calibration check. So finding out this, where you can apply updates immediately or just in time, let's say it in that way, even for safety relevant components, and the update works, is very important. And then to have the second group as well ready, where you go to other procedures, because the other procedures are the most expensive ones. I mean, and then we are again in this economics. And you can put this for every industry, connected industry, even for a machine. I mean, if you have a machine running on site and there are some criteria on there on how the machine works, is it precise enough? Is the quality enough? Usually the machinery in the industry don't want to apply updates because they are afraid that the downtimes or loss of quality and so on due software.
Yeah.
So we need other procedures to enable them to do that with a high trust that it works. Let's say it in that way. And we are not used as a software industry on doing that. If you take the IT department, I mean, I don't see the audience here, but raise your hands now if you have ever applied a software update on one of your device and the device was not working afterwards.
Definitely.
I mean,
everybody's had this experience, right?
Absolutely.
You hear a lot of thumbs up.
I mean, on the IT, and it's let's say we have accepted it. I mean, it was uncomfortable maybe, but we have accepted it. But there are connected applications out there where it's not acceptable. I mean, apply a software update on a car and it's not working anymore. That's maybe a pity. Apply it on a production facility and the facility has a downtime, and you call your IT department, they say, whoa, whoa, it was the update. You have to reboot. Wait, it took 8 hours. I mean, it's not acceptable in this world. So we need other procedures.
Yeah. Definitely recognizable, I think. Another question just sort of popped in. Somebody's wondering if there's any kind of regulation that will enable this kind of data collection that you've been talking about from especially IoT manufacturers.
in terms of that manufacturers are forced. There are some, let's say the regulatory side is very easy. They just say, for example, you have, as an OEM, you have to implement a cybersecurity management system, and you have to secure the supply chain. I mean, that's what they are writing in a nutshell. They don't tell you how to do that, and even if it's possible or whatever. But that's the regulatory side. And then we have to find our answers there. So the NIST directive, the Cyber Resilience Act, even the radio equipment device directive, there's a lot of things popping up talking about securing the software stack and the supply chain, but they don't tell you how to do that. But as I see the European landscape, how regulation is built, of course, it's all like building blocks coming together. So these are maybe the most important for software security. So the Cyber Resilience Act and the NIS2 directive. But it's getting complex. If I look at the car, the next one will be the AI Act. I mean, if you have components running AI on your edge, then these components are as well under the AI Act, and then you need to take other measurements. Even the term IoT is, I mean, it's outdated, isn't it? Because
what is it really? Yeah. You were talking though about sensors, so maybe that's part of what's going on in this question. I would maybe just venture to guess there. So if you're looking at something like some kind of small sensor type of component in a car or another type of vehicle, and you were talking about how those things get embedded into another product that then somebody puts into something that's actually doing some kind of functional something. That's maybe part of what you could be thinking about here. I mean, are there is the regulation really going to give you, because I think that's maybe part of the problem people have been seeing in practice, is it going to give me, somebody like me who's working for an organization, is it going to give me a way to actually, go to these end level suppliers and say, you have to give me this information? Because some of this is also IP based. So that's part of what you run into there in practice.
Exactly. That's the practical problem. And even like if you take the suppliers, the end tier suppliers, there are as well great examples out there. Like if you have a semiconductor supplier providing the specific semiconductor for the sensor, they have as well the problem that they don't know which semiconductors are built in which products by the OEM, because they are too far away from the OEM in the supply chain. Yeah. So if they find out that they have a software quality problem on one of their semiconductors, they can't identify the OEMs which should be addressed for this update and patch because they don't know them. And this is really a situation which is for both sides not very good, let's say it in that way.
Yeah. That was one of my questions as well, Mirko. I tried to type it in there, but I didn't get through. So if you look at basically, it's as strong as the weakest link. So looking at it maybe a little bit negative from a negative perspective, do you think that at the end of the day, the lawyers again are going to be the big winners? Are you positive in where we stand now? Because from what you told me, you mentioned at the beginning of the presentation that there's a risk of the SBOM not being trusted. After your presentation, I'm much more afraid that the SBOM is being trusted. That could be even bigger challenge. It really requires a very high level of maturity before because I think the technology is all there, basically, but it requires a very high level of maturity to start with automation. So putting it all together, if you look at the audience, and not all will be in the OT environments as well, what would you recommend to them to take their first step in this domain?
If you look into the supply chains, I think it's like the one we are talking about technical problems, isn't it? But to me, it would be as well a question how you define the responsibility of your suppliers towards software. Like if this is part of what is the part of the supplier contracts and how to provide this information and what level of informations, and this is more the lawyer side and the purchasing side of your business. But you see how complex it's interconnected. If you want to get it into a trustworthy information, you need the software side, of course. You need the implementation in your own organization to deal with software bill of materials, to have the CI/CD pipelines ready and so on. But you need to tie it as well into the contractual relationship towards your vendors. And then you are in supplier management. And then you have to deal with your purchasing department as well, how to tie it in. But I'm very positive on that, because for GDPR, we have managed that. It's not a new procedure. On GDPR, it was exactly the same questions. We need to know if any vendors are supplying products which are dealing with data, blah, 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 that it needs to be part of a contractual situation, that there is the GDPR approval side as well in there. And I think you need exactly the same procedures and tools you already have applied for GDPR for software bill of materials.
Do you think that GDPR is a bit more prescriptive on that? And
yes.
that, of course, if you are my vendor, I would provide you, like it's being done today with third-party vendors. I would put together a questionnaire. You would fill it out. You would sign a contract. But then you also have your third parties as well, and you will use a completely different types of data set for asking questions. Do you see any type of progression there, or is it even required to have a bit more standardization there over the entire chain?
From the regulatory perspective, of course not. They just simply say do. You can do it with Excel if you are happy with Excel, but I believe you will end on a horrible situation. We see it now, like I can talk a little bit about what I see in the German industry. But there's, for example, like a high demand of standardizations on SBOMs, like Cyclone DX as a standard, and as well collaboration with across the industry. And this is a very good sign. So even like they're contributing to open source, unbelievable. I mean, vendors who build really closed firmware stack in the parts are now contributing to open source projects, because they all see the same problem. If we don't fix it, this interoperability, we can't get into a trusted level of software bill of materials, and then the overhead will kill them. It's definitively not the way it should go.
Okay, great, thanks. I see Andrea's hanging into her new meeting. She's she's knocking on my door that we have to close off.
I just wanted to give us a little minute here to sort of do a little wrap up. There are no more questions in the chat, so it's a good time, I think, to put a little a conclusion in place. So I think my sort of takeaway, Mirko, thanks to you today, is that there's definitely a perspective that we can work towards where this is going to be functioning for us and helping us to deal with, the regulatory compliance, which just basically says go do something, right? I think we all have a little bit better view of what we could be doing, but I think there's still looking at it a lot of work to be done to really get things implemented and in place. But I would like to thank you, I think, for everybody who's been listening, for giving us this view of how you've been working on this and the kinds of insights it's been giving you. It's giving me, at least me, some new ideas, some things that are maybe old ideas that I need to dust off again, that things like I won't be able to patch everything every time, every place, because that's definitely something I've run into before, but that I'm maybe not actively promoting as much as I should be in discussions in my internal organization. And also just to think about that idea of self-healing. I think that's something definitely great that we could all, be thinking about more, and also asking maybe providers that we already work with to help us do more things in that area as well. Even if you're not working in the OT environment, in a cloud environment, these kinds of models can definitely also, I think, be implemented, and we're maybe not doing that as much as we should be. So something, I think, some food for thought to go into this Monday afternoon. And I would just like to thank you very much for joining us today. Wim, I don't know if you have some closing words for the group before we go.
No, nothing but thanks. Thanks to you, Mirko. Thanks to you, Andrea, for all your support over the last. It's not as visible because you're not promoting yourself on LinkedIn, but I know that you do a lot of work for the community, and it's really appreciated. Mirko, it was a pleasure. To the audience, there are some additional slides. I will just send them over. There are some events coming up after summer. So you are relieved from spam for the next 2 months at least, and this is recorded, so you have it on video. We hope you enjoyed it, and we wish you a very nice and warm and hopefully not too warm summer, and we will see each other again in September. Thank you, everybody.
Thank you very much.
Thank you.
See you. Ciao.
Bye.
Bye.